Hello friends. In this video tutorial, we're going to learn about what are complex numbers. So in the past classes, you have been dealing with only the real numbers, and to solve such equations, you were unable to find a real solution. So to introduce, let's first of all talk about what is the symbol iota. So to find the solution of such an equation, you need to have the in the you need to have understanding of what this symbol is. So as you solve this equation, you notice that the d of this equation is less than 0. So a new symbol was introduced which whose value was equal root minus 1. So as you can see, this satisfies this particular equation. So basically iota was introduced as the another symbol whose value is root minus 1, or in other terms the solution of this equation. So the complex number were now given as a number of the form a plus iota times b, where a and b are real numbers. So the first real number, that is a, in to represent, which is used to represent the complex number, is called the real part of a, as it is, as you can see, basically a simple real number. It can be anything like 2, root 2, or anything of this sort. And the second part, it's multiplied by this exponent, by this constant iota, as you've learned in the earlier slide, and so it's called the imaginary part of the complex number z, and it is denoted by im bracket z and equals to b. So let's work out some of the powers of iota, that is what is iota to the power 2, iota to the power 3, and so on. So to work out these, we need an important result which says that root a into root b is not equals to root ab when a and b are both negative. That's to simply say, we have to look into what is a and what is b. Say for example, if you solve what is iota square, you can't simply put it as root minus 1 into root minus 1, which, as from the previous knowledge, you would have put equal to root of minus 1 into minus 1, which would have come out to be, from the previous knowledge, as 1. So as you can see, it comes out to be minus 1, so it's wrong. So you have to grasp the concept that this, to solve such equations, you have to carefully note that what are a and what is b. Okay, so here I just keep a note that when a and b are both negative, you use the concept of iota and put it as express this a or b, any one of them, in terms of iota multiplied with a root of a positive number, to use this property. Okay, so let's calculate what is iota square. Just keep in mind it's minus 1, and iota cube, it's simple to work out iota cube as by writing iota cube as iota square into iota, and as for the previous example, you know that iota square is minus 1, so it comes out to be minus iota. The next is iota to the power 4. It is a pivotal thing to note that after you multiply iota 4 times, that is iota into iota into iota into iota, you get 1. So iota to the power 4 is equal to 1. Therefore, as you note, if you multiply iota to any power of 4, that is iota to the power 4n, you'll get 1. That is to say that iota to the power 8 is also equals to 1, iota to the power 12 is also equals to 1, and so on. This helps us to calculate the high powers of iota. That is, if you want to calculate, say, iota to the power 99, it's simple to calculate. Just divide the exponent with the with 4 to obtain the remainder, and just see from the lookup table the value of the particular iota raised to the remainder to get the value. Say for if you are calculating iota to the power 99, it's just iota to the power 3, as iota to the power um, 96 is equal to 1, as 96 is a factor of has a factor 4, and as you can see from the lookup table that iota cube is equal to minus iota, so the value comes out to be simply minus iota. Just keep in mind these concepts. It will be helpful to calculate higher powers of iota. Okay, so as we have some knowledge of what are complex numbers, let's look into how to uh, do the algebra of complex numbers. Like we have introduced, you would have learned in the earlier classes about real numbers. So first of all, look into when are two complex numbers equal. Let's say there are two complex numbers, z1 which is equal to a1 plus iota b1, and z2 which is equals to a2 plus iota b2, and let's say they are equal. Then it implies simply that the corresponding real part and the imaginary part are equal. That is to say that real part, which is the first number a1 and a2, are equal, and correspondingly the imaginary part, which is the b1 and b2, are also equal. Okay, next let's look into how to add two complex numbers. So similarly we have z1 and z2, and to add z1 and z2 it's simple to individually add the real part and individually add the imaginary part and get the answer. That is when we add two numbers, the corresponding answer or the result will be the complex number formed by the sum of the individual real parts plus iota times sum of the individual imaginary parts. So to get a clear idea, let's just take a simple example. Say z1 equals to 2 plus 3 iota and z2 equals to 4 plus 2 iota. When you add two numbers, there's z1 and z2, you add the corresponding real numbers, that is 2 plus 4 plus iota times the corresponding imaginary number, that is 3 and 2, to get the answer, that is 6 plus iota times 5, hence the answer. As you might have learned in the real algebra of real numbers, the addition simply follows some of the basic properties like the closure property, commutative property, associative property, and the existence of additive inverse and the additive identity. So let's look at them one by one. Okay, so the first thing is the closure property. That is to say that if z1 and z2 are two complex number and they are added to get a third complex number, that is z3, then z3 will also be a complex number. The second property is that of commutativity, that says that if z1 plus z2 gives a certain number, that's let's say z3, then if you add z2 first and then z1, it would yield the same answer. The next property is that of associativity. It's simple to follow that z1 plus z2 and then subsequently adding z3 will yield the same answer as if you add z1 to the result of the addition of z2 and z3. The next property is that of the existence of the additive inverse. That is to say, if z1 is a complex number, then we can find a complex number, say z2, which is also which yields the answer as 0 when added to z1. This is simply written as z2 is equal to, which is equal to z2 is equal to minus z1. That is equal to, if z1 is equal to the same, the a1 plus iota b1, so it will be minus a1 plus iota, sorry, let's be it plus iota times minus b1. Okay, the next one is the that of the additive identity. That is there is a complex number 0, which when added to any other complex number, say z1, will yield the same as z1. Just keep in mind these properties. It will be helpful to solve some, get you a feel of what are complex numbers. Next thing we introduce is that of multiplication. It's a bit I would say like that of the solving the factors of 2. Say if you when you multiply x plus 2 with x plus 4, say, so you take x as a variable. Just do the same with iota and it will be easier to solve. And for example, let's try to get a feel of what is z1 z2. What z1 let's say z1 is equal to a1 plus iota b1 and z2 is equal to a2 plus iota b2. Then if you multiply z1 with z2, what you will get is, first of all, first term will be a1 into a2. Next term will be a1 into, let's write down. The first term will be a1 a2. The second one will be iota times a1 b2. The next term will be iota times b1 a2, and the last term will be iota square times b1 b2. Okay, so as you learned from the earlier classes that iota square is equal to -1, so it will again yield the same answer. That's just this is just a factorized form of the this particular thing, which says that a1 a2 minus, that is for the iota square, b1 b2 plus iota times a1 b2 plus b1 a2. So let's work out a simple example. Say z1 is equal to 2 plus 3 iota and z2 is equal to 4 plus 5 iota. Then we have z1 z2 as equal to, just compare it with the standard form and simply put in the values to obtain a1 a2. a1 a2 minus b1 b2 is plus iota times a1 b2 plus b1 a2 to obtain -7, that which is equal to 2 into 4 minus 3 into 5 plus iota times 22, which is 5 into 2 10 plus 3 into 4 12. So 10 plus 12 yields us 22. It's a simple algebra. Just keep in mind this symbol iota and multiply it accordingly. It also follows certain properties like that of the closures, which says that if you multiply two complex numbers z1 and z2, then the answer is also a complex number. The next is that of the commutativity, that is, if you multiply z1 to z2, you will yield the same answer when you multiply z2 with z1. The next is that of the associativity. Associativity property is very easy, it's very similar, but sometimes very useful when you want to multiply two complex numbers. You may be able to avoid this particular expression if you multiply handsomely. Okay, so the associativity property is simple. That is to say, if you multiply z1 and z2 first and then multiply z3 to its product, you will obtain the same answer as if you multiply z1 to the product of z2 z3. These properties are simple. The next one is that of the distributive law. It is helpful to solve the questions which says that if you are given to multiply z1 with the sum of z2 z3, you will yield the same answer as z1 z2 added to z1 z3. This is the distributive law. The next one is that of the additive the multiplicative identity, which says that if you multiply, the multiplicative inverse of any number is equal to, let's say, z2 is equal to 1. It will satisfy the simple property, and which will yield z2 is equal to 1 upon z. So let's work out what 1 by z1 would be. Let's take z1 is equal to a1 plus iota b1, then z1 will be a1 plus iota b1, and if you just rationalize it, you will get simply just rationalize it, you will get a1 minus iota b1 upon, you will multiply to rationalize it, you will multiply it with a1 minus iota b1 to get a1 square minus iota b1 square, which is simply, as you can see, iota square will yield a -1, and you will get a1 minus iota b1 upon a1 square plus b1 square. Just keep in mind this as it will be very useful. And the last one is that of the multiplicative identity, which is simply a complex number 1. If you that says that if you multiply any number with the complex number 1, you will yield the same answer as the number itself, that is z1.